Today we're doing 13.2 using the solving quadratics using the square root method. The homework will be page 583, number 1 through 41 on. Okay. All right, let's get started. So I'm going to remind you that when we use our square root method, we do not set it equal to 0. We get the quadratic, the x squared, all alone. And then I'm going to take the root of both sides. Now, to really understand, remember when we take the square root of x squared, we get an absolute value. Now, why was that? That is to account for our negative numbers. So remember back when we did the square root of x squared is equal to the absolute value of x. And then we said the square root of x cubed is equal to x squared times rad x, and so that would be x rad x. And we had x to the fourth, which was x squared. And we had the square root of x to the fifth is x to the fourth times rad x. So that would be x squared rad x. And then I had the square root of x to the sixth, which is exactly x to the third. And when we have an odd result all alone, we end up here to account for our positives and negatives. So since x squared, the result is x to the first, that's an odd result all along, then we take the absolute value. And when we take that absolute value, in order to lose it, we set the number to the positive or the negative. Now, I do want you writing this step. I don't want you to just jump from here to here. I want you writing that in-between step. Okay? We're working out of the green book, by the way. So here we go. And so we have two solutions, positive 3 and negative 3. Nobody wants to write plus 3, comma, negative 3. Too much work. So just write plus or minus 3. It shows the two solutions. All right, so I'm going to do it one more time. We're going to root both sides. And the square root of x squared is the absolute value of x, and the square root of 36 is 6. So absolute value of x equals 6. To lose the absolute value, I get x equals plus or minus 6. Okay, pause the recording and try the next one on your own. Great, let's check our work. So now I'm going to do the root of n squared is equal to the root of 169. And then I get the absolute value of n is equal to 13, and n is equal to plus or minus 13. All right, we get something like this where we have an odd number. It's not a perfect square. When I root both sides, it's not a perfect square. But I'm still doing the same thing. Leave it under the radical. Do not estimate it. If it's just a number problem, do not estimate it. It's far more accurate under the radical. So I get the absolute value of y is equal to rad 7. To lose the absolute value, we're doing y equals plus or minus rad 7. Leave it under the radical. The next one, before we can do anything, we have to isolate the variable. So I have to get rid of the minus 6. So why don't you pause and try that one on your own. Okay, now check. I'm going to add 6 to both sides. Now my radical is alone. My square is alone. So now I can root it. Root both sides, property of equality. Absolute value of m is equal to rad 13. M equals plus or minus rad 13. All right. Something like this. We have to get that quadratic all alone. We got to get the y squared all alone. So I'm going to peel it like an onion outside first. What's the opposite of minus 20? It's plus 20. We're going to zero that out, add 20 to both sides, property of equality. What's the opposite of multiplying by 3? I'm going to divide both sides by 3, or multiply by a third. Y squared equals 16. I'm going to root both sides. Absolute value of y is equal to 4, and y equals plus or minus 4. Okay? Pause and try the next one on your own. I'm going to add 16. Let's check our work. Okay, let's check our work. I'm going to add 16. Divide both sides by 2. I'm going to root both sides. Absolute value of x equals rad 10. X equals plus or minus rad 10. Okay. All right, let's try the next few. I'm subtracting. Why don't you try these on your own? Pause the recording. Okay, let's check our work. So on the first one, you should have got through with it pretty quick because as you subtract the 30, right now I'm already seeing a problem, but then I'm going to divide by 2. Still see a problem. Now, as I'm here and I go to take my square root, you'll notice I end up in a situation where I'm taking the square root of -7, and we can't do that. So we say no solution. So whenever you get yourself into a situation where you're taking the square root of a negative, you have to say no solution. Okay? Next one, I'm going to add 2 to both sides. This one's a little bit more unusual. And then I'm going to divide both sides by 5. So it's okay. We can take the square root of a fraction. So I'm rooting. Do not switch that to a decimal. I'm going to root both sides. Okay. I get the absolute value of x equals rad 3 over rad 5. Now, the thing is, we are not allowed to have a radical in the denominator. Remember, chapter 11, we have to rationalize it. So I'm going to have to use my property of equality and multiply by a fancy 1. Not my property of equality, my identity property, right? The fancy 1. This is the fancy 1. When you multiply anything by 1, it stays the same. So I get rad 15 over 5, and it's plus or minus rad 15 over 5. Remember, leave it in the radical form. We want it in the radical form. I only want you to estimate if it's a word problem. And they want, we don't say rad 15 seconds. So in that case, you would estimate. Okay, let's keep going. Binomials. I had a lot of kids that had problems with this before, so it's the second time. We're going to root both sides. Okay. And then remember that binomial is to the second power, so I'm ready to root it. As soon as the quadratic is isolated, there's nothing outside like a 5 over here, plus 6. It's ready to go. There's nothing on that side other than the quadratic. So I'm going to root both sides. And then I get 4 on the right. And on the left side, I'm putting y plus 1 in absolute value. Okay, and now I'm going to, I have a lot of people here, they don't take the absolute value. But here, you have to lose it before you can work inside. So to lose it, we have to set it equal to plus or minus 4. And then I can deal with that plus 1. Now I can isolate. You can't isolate the y before dealing with the absolute value. So lose the absolute value, you gain the plus or negative. Now I'm subtracting 1. Now what this means is -1 plus 4 and -1 minus 4. And -1 plus 4 is 3, and -1 minus 4 is 5. And so my solutions are 3, -5, or -5. You can put that in your solution set. Right? You can put it like that, or you can just, I don't care how you do it. I did it in the PowerPoint. All right, pause the recording and try the next one on your own. Now let's check our work. I'm going to root both sides. The quadratic goes alone. Now remember, absolute value of x minus 3 equals 5. Now, I have a lot of people, don't do this, that do this first. And then they take the absolute value. You're going to get a wrong answer if you do that. And then they say, well, x equals plus or minus 8. No, before you can work inside the absolute value, you have to get rid of the absolute value. This is the point. There's nothing on the outside, so we have to get rid of it before we can work inside. So to get rid of it, I have to set it equal to plus or minus 5. Then I can add 3 to both sides. And then I get 3 plus 5 and 3 minus 5. I get 8 or negative 2. Now I had somebody ask last period, well, don't we know that the absolute value of negative 3 is 3? That's not how we do it. We have to take the absolute value of the binomial. And remember, there's only 2 answers that go in here. So 8 minus 3 equals 5, right? That's a 5. Absolute value of 5 equals 5. And then what happens if I get negative 2 minus 3? That's negative 5 equals 5. So both of those work. Those are the only 2 answers that work, not the plus or minus 8. If you wait and take the absolute value at the end, you will be getting it wrong. So let's fix that now. Remember, as soon as you see the absolute value, we lose the absolute value and gain a plus or minus on the opposite side. All right, height of a falling object. So acceleration due to gravity. We did this before when we're talking about a penny dropping from the Empire State. The h generally means our ending height of the object. Where we start, where we end. H is the ending height. C is the initial height. And T stands for time. So a while ago we did the penny drop from the top of the Empire State, and we used the equation. And then we're given in this equation 448 meters. That's it's dropped from, so that becomes our initial height. C is 448. How long will it take? We don't know. And H is the ending height. What would the ending height be if it's on the ground? That's going to be 0. So I substitute those in. And it doesn't look like this is anything that can be factored, so basically I'm going to use the square root property. I'm subtracting 448, and then I'm going to divide by 5. And when I divide, I'm going to get a decimal. Now, this is going to have to be estimated, okay? They want to know how long. That's the question, how long? So now I'm going to root both sides. I'm going to take the square root both sides. And I'm not going to do the absolute value. I'm not doing like what we did before, right? Take the square root, and then we get the absolute value of t because we don't want the negative value. Time can't be negative. So I know that t equals the square root of 89. That's about, t is equal to about, let's go, that's between 81 is 9. The square root of 89.6, that's 8.6. And then I've got the square root of 100, right? Square root of 100. I kind of estimated this to 90. It's about 9, that's about 10. So I'm almost going to guess 9.5 seconds. So, and we're going to use that little about because it is 9.5 seconds. It's pretty close to the middle. Okay, word problems we are going to estimate. Non-word problems, reduced radical. Okay, vertical motion. Vertical motion is where we add velocity. Okay, same thing, we're using the same equation. We have our height, our ending height. H stands for ending height, T stands for time, and C stands for initial height. Okay. When we add our object being thrown upward, here we're just dropping it. When we add velocity, that's pushing something up, and we're seeing where that goes, right? We're going to push it up, throw it from a certain height. We're going to push it up, and there we go. It's got what goes up must come down. So that's velocity. It's almost like the speed, but it's got a little push to it. It's got some force to it. okay? Initial velocity. So that's the equation we're going to use now. So I use the h equals, remember, oops, let's do this. Okay, we could drop it. I mean, we can draw it. Our 40 is we're dropping from a 40-foot cliff. How long will the ball thrown upwards? So I'm taking the ball on the cliff and I'm throwing it up. It's going to make a natural parabola upwards at 10 meters per second. Let's first look at this. My c is 40. What's my velocity? It's 10. How long will the ball be thrown upwards to stay in the air? We don't know the time. They want to know how long. If it's thrown from a 40-meter cliff. Okay, so now what I'm really missing here is my ending height. For it to hit, not be in the ground, not be in the air, it's the ground, and it would be 0. Okay? So we can just substitute that into the equation. They'll usually give you the equation. Okay? Here's the equation, and you substitute and factor. 10 is the velocity, 40 is the initial height, and 0. So first I'm going to divide by -5. I get t squared minus 2t minus 8. What multiplies to -8 and adds to -4, right? Sorry, adds to -2. I got -4 and +2. So here t equals -2 and t equals 4. So time can't be negative, so it would be 4. So it's 4 seconds. Okay? All right, let's try it again. Start with your formula, same equation, same equation. And most of the time they will give you this equation in physics or in math, and it's really just a substitution. So let's look. We need to find out the c, the h, the velocity, and that v sub 0, that means the velocity, the starting velocity at 0 feet, right? Okay. And we've got the, or not 0 speed. We've got the c, the h, and then we have the t. We don't know what our t is. It says how long again? Pause, see what you can do. Okay, let's check our work. So hopefully you got your initial height of 8. Your velocity was 6. And your h is 0. And so we substitute it in. Now, right away, I'm going to divide by -1 to not have the lead coefficient negative. Or I could have just multiplied by my... So if I multiplied by my lead coefficient, I could have really multiplied, but my PowerPoint was... I could have multiplied by -1. So what multiplies to -40 and adds to -6t, t squared? What multiplies to -40 and adds to -6, it's -10 and +4. So this becomes t plus 4 times t minus 10. But remember, we multiplied by 5, so we have to divide by 5. And we get 5t plus 4 times the quantity of t minus 2. So t minus 2 over here, t minus 2, t has to equal 2 seconds. Over here, this one's not going to work. It's going to end up being negative. Subtract 4, there we see the negative. 5t equals -4. Divide by 5. T equals -4/5. And time can't be negative, so our time is 2 seconds. Okay. Okay, last problem. Interest, okay? When we talk about interest, annual means yearly. Compounded, this is the formula we use. The other interest formula was I equals PRT, or principal plus I plus I, or principal plus PRT. So this is when it's compounding annually, meaning you're paying interest on the interest as well. We use this formula. A stands for the total amount in the account. P stands for the principal or starting amount. And R stands for your rate, and interest rate, it's usually a percent or a decimal, and T stands for time. Now, this one can be used for either investing or borrowing. It's the same math. So here's the word problem, and let's use our equation. So if 500 is invested for 2 years and the interest is compounded annually, what interest rate is needed to increase the total in the account to 540? So my total in the account is 540. The A is 540. Okay, the A was 540. Let's say my principal is 500. My time is 2 years. And so we don't know what our interest is. So I'm going to substitute, or interest rate, I'm going to substitute in. Now I need to get that quadratic alone, so I'm going to divide both sides by 500. I'm going to reduce it as small as I can as a fraction. First divide by 10, then divide by 2. Now I'm going to root it, both sides. Root both sides. I get the absolute value of r plus 1 over rad 27 over 25. We know on the bottom it's a 5. Now my PowerPoint does it a little bit different in that they reduce the radical first and then find the value of it. But we have to, if you're using a calculator, I may as well find the square root of 27 and then divide it by 5. So when I do that, square root of 27, or 3 rad 3, we could say it's 9 rad 3, 3 rad 3. It should equal close to, if I use my graphing calculator, 5.196152423. And so if this is minus 1, okay, they want to do it that way, and then they're going to simplify it. So here we go. Again, I would just simplify this down. I probably would have simplified it at this point, not done a reduced radical, because it can't give the answer in a reduced radical. So I would have had r equals -1 plus or minus 5.196152423, right? All over 5. And when I'm going to first simplify this fraction. When I reduce it, I get r equals -1 plus or minus 1.039. So I'm going to just round this to 1.04. R equals -1 plus or minus 1.04. So what this means is -1 plus 1.04, 400ths, 1 and 400ths. And so that equals 0 and 400ths, or -1 minus minus 1 and 400ths. That would be -2 and 400ths. Well, interest can't be negative, so my interest rate has to be 400ths, and when I convert that to a percent, it will be 4%. Okay, and that is the end of the lesson. If you want to see the way my PowerPoint is, I'll put it back up here. It's a little bit clearer. And we're doing the about because we cut off a lot of decimals. Now remember, I really cut the decimals, and I didn't cut them off. I cut them off right when I had the square root of 27. Not before I divided the 5. All right, that's it. See you later.